Right, so we're gonna start with not Euclidean, analytical geometry. Okay, so on analytical geometry, this is just the summary of the formulas. This I think is from, I don't know if this was in grade 10. Yeah, I think it's from grade 10. So, okay, so the first thing you have is the average gradient. Average gradient of a line is of the line passing through 2 points, points A and B. In this case, it will be your y, change in y over change in x. So that's just the normal gradient, whether you're going to have y2 minus y1 over x2 minus x1. Okay, the normal gradient of the line. So that is that. So if they were giving you 2 points, they ask you to calculate the gradient of that line. That's the equation you're going to use. The next formula is the distance formula. So if they ask you to calculate the distance between 2 points, this is the formula you're going to use. So AB squared, which is that distance, is going to be a change in y squared plus change in x squared. So either y2 minus y1 squared plus x2 minus x1 squared, whatever you decide to use there. Okay, then if it's AB squared, then AB will be the square root of this whole expression. Okay, so that's the distance formula. Then we've got a midpoint. Midpoint of a certain line will be average. So it will be the first x coordinate plus the next x coordinate divided by 2. So that's the midpoint. So if you are given, maybe this is 2 and 1, and this is 4 and 5, and they ask you to calculate the midpoint to determine the coordinates of the midpoint. So you're gonna use this formula to get the coordinates of this point here. Okay, so you'll have your 2 plus 4 divided by 2, then 1 plus 5 divided by 2. So that's how you get your midpoint. Okay, then you've got angle of inclination. So that certain line will be sitting at the certain angle. So for you to calculate that angle is actually is the gradient of that line. So the gradient, which is m, but gradient is the same as tan theta. Remember tan theta, if you remember your grade 10 and grade 11 trigonometry, tan theta is opposite over adjacent. So if you had a line here, your opposite will be the y value, your adjacent will be the x value. So that's why you have change in y over change in x. So the gradient is tan theta. Okay, then you're gonna calculate theta. And for you to calculate theta here, theta will be second function of tan, and that values that x over, that y over x, sorry. So that's how you get your theta. We will see when we do examples. Then the next thing is equation of a circle. So equation of a circle, this is the formula. You have x minus a squared plus y minus b squared is equal to r squared. Your a and b, those are coordinates of the center of the circle. Okay, then you've got equation of a straight line. Equation of a straight line is y is equal to mx plus c, or is the change in y. Change in y is equal to gradient times change in x, which is, this is the same as, you can also get your equation of line by getting the gradient, change in x over change in y. Change in y over change in x, sorry, which is your y2 minus y1 over x2 minus x1. So then your equation of a line, you write it in the form of y. So that's why now then you can have this as your equation of line, or you can use that to get your equation of line. Then once you get the equation of line, you will have gradients gradients of a perpendicular line. So if we've got two lines that are perpendicular, their gradient, when you multiply them, they're going to give you a -1. So if you are told that these two lines are perpendicular, so their gradient, when the product of their gradients, when you multiply the two gradients, they must give you a -1. Okay, so that is that one. Then the gradient of parallel lines, they are equal. So gradients of parallel lines are equal. So that the m of that certain line will be equal to the m of that other line if you are told that those two lines are parallel. Okay, let me just check. Someone is struggling to connect to the meeting. Okay, so that's it. So let's just do summary of everything that is on the Euclid, on the analytical. I keep on saying Euclidean because I've been doing Euclidean geometry. So we've got the equation of a circle and that. Then also you've got straight line and tangents. So straight lines and tangents to the circle. Okay, so a tangent to the circle is a line drawn from outside touching the circle at one point. So this will be the center of the circle. This will be your radius. So this is a tangent. This will be the radius. Okay, so a tangent to a circle is always perpendicular to the radius at the point of contact. Okay. So steps to finding the equation of a tangent. If they ask you to find an equation of a tangent to a circle when the point of contact is given, so you will need to find the gradient. So let's just do an example so we follow the steps. So they say to you, determine the equation of a tangent to the circle. So you are given a circle, x squared plus y squared is equals to 8. So they say, determine the equation of the tangent to the circle, this circle at the point A, which is 2 and 2. Those are the coordinates. Okay, so they want equation of a tangent. Equation of a tangent here. Okay. So the step for you to find the equation of a tangent when the point of contact is given, you first find the gradient of the radius at the given point. So gradient of the radius, the center of the circle. Okay, we have the circle here, right? So the circle is x squared plus y squared plus 8. Remember the formula for equation of a circle is for x minus a squared plus y minus b squared is equal to r squared, right? We said a and b are the center points. So can you see here we've got x minus 0 squared plus y minus 0 squared, which is equals to, this is an equal sign, sorry. Okay, which is 8. 8 is the same as, yeah, square root of r, square root of 8 squared. So that's that. So you see that the center here, it means it's a 0 and 0. And then point A is a point of contact. So we have 2 and minus 2 here. Okay. So guys, if you've got a question, you are welcome to unmute your mic and ask me. Okay, so that's that. So now we want first, they said the first step when you need to determine the gradient of a tangent, you first find the gradient of the radius. So let's find the gradient of the radius. So m is change in y2 minus y1 over x2 minus x1. So let's take this as 1. and this as 2. So we're going to have y2 is -2 minus y1 is 0. x2 is 2, x1 is 0. So our gradient is -2 over 2, which is -1. Okay, so that's the gradient for the radius. Now we said the gradient, the tangent is always perpendicular to the radius. So if the gradient is always perpendicular to tangent always perpendicular to the radius. And we said if you've got two lines that are perpendicular, their gradients, when you multiply them, they're going to give -1. So now we know the gradient for the radius. So radius is at, we use 0.1, which is -2, -1 times m2 for the tangent -1. Then can you see m2 is 1? Okay, so that's how you get, that's the gradient for the tangent. That's how you get that gradient. Okay. Then, so you get the gradient, and then use the given point of contact and the gradient of the tangent to work out the equation of a tangent. So if they were to ask you now, after you got the gradient, they ask you to find the equation or determine the equation of the tangent. So equation of the line we know is mx plus c. You got your tangent is 1. Your gradient, sorry guys, x plus c. Now you take the point on that line. We have point A on the line that we're looking for the equation. So we've got point A, which is 2 and -2. Those are the coordinates. So we take these coordinates, substitute them here, we get the value of c. So then let me just change the setting because I see Ruth keeps on coming in and going out. Let me just change my settings here so that you guys can just join in anytime. Let me see. Change the waiting area. Okay. So if someone is kicked out, they can just come back in. Okay. Right. Okay, so that's that. So then let's find c here. Y is -2, x is 2 plus c. Now can you see c is -4? Therefore, that equation of the line will be x minus 4. Okay, so that's that part. So those that just came in, if you've got a question, just unmute yourself and ask the question. Stop me and ask the question. Okay. So that is that. So yeah, that's just the summary for analytical. It's nothing big. So I'm gonna go straight to the previous question paper, which is a question paper from 2017, grade 12 question paper from 2017 November. But it's both grade 11 and grade 12. So that's type of a question, you will find it in your grade 11 exam and you will also find it in your grade 12 exam. Okay, so let me go and get the, did I open it? Right, let me stop sharing here and share the question paper. Right, let me see, where is it? Yeah, question 4. Let's look at question 4. Okay, so let's read question 4. In the given diagram, P, which is has coordinates -4 and 5, and K, which has 0 and -3, are the endpoints of the diameter of a circle with the center M. Okay, so you can see that on the graph. Then S and R are respectively the X and Y coordinates of a tangent. Okay, so X and Y, S and R, let me see if I'm going to be able to write here. Okay, so S and R are the X and Y intercept of the tangent. So can you see this line SR is a tangent? That's what they're telling you. And then they say theta is an inclination of PK. So theta is an inclination of PK. Remember we said that angle of inclination, tan theta. Well, this is not supposed to be for writing. So, okay, let me just leave that one for now. So that's the angle of inclination. Then they're asking you determine, the first question is determine the gradient of SR. And then the next question will be determine the equation of SR. So once we determine the gradient of SR, we need to determine the equation of SR. After that, we need to determine the equation of the circle in that form. And then at the end, get the angle PKR. Angle PKR, yeah. Okay. Okay, so let's go back to the screen. I hope I have this somewhere on my phone so I can copy. I don't think I have it. It's gonna be very far. Right. Let me just draw it down. Bear with me. Because now I won't be able to copy it. Let me just draw the circle. For the circle, we've got the tangent. We have P, which is -4 and 5. We've got center M. And then what's happening here? Passing through the center. Okay. All right, so let's see. We're given a circle like this. Center M.